J6. Oh. Throwback Thursday. A listing where order is important. Alright, so sometimes when we list things, that order is really important when you make your sandwich. Some people, sandwiches are a really big deal with permutations and combinations. Some people, when they make their sandwich, they're like, oh, just put on some turkey, some lettuce, and some tomatoes. And they don't care if it goes tomatoes, lettuce, turkey, or turkey, lettuce, tomatoes. Some people, when they make their sandwiches, they're really, they want their sandwich to be made exactly the same. They want that turkey first, then they want lettuce, and then they want tomatoes. Okay? So they want it to be exactly in the same order every time. And so that's kind of where our permutation comes in, is that we want it in that certain exact order. Kind of like when we get dressed in the morning, do you just grab a piece of clothing and you just put it on? And then you grab the next piece of clothing and put it on? No, you got to put certain things on first, right? Can't be walking around with our underwear outside of our pants. It would look like a weirdo. All right, so to do permutations, we use this function. It's called the permutation function. We do a lowercase n. It's an uppercase P, so capital P for permutation. And then a lowercase r, and this is what it looks like in our calculator. We have this n and r. And then in parentheses, we'll actually put a number here, and this first number will be our n, and our second amount will be r. And this looks really silly right now, because you're like, what the heck are these n and r's and p's? P stands for permutation. All right, n stands for our total objects. And R is going to stand for the amount that we need. All right, so the way that we say this when we see something like this is we say it's a little bit different. We say a permutation we use that word of, which we normally use when we see those parentheses. Permutation of, and now this is the part that's different, n, and we use this word choose. Oops, that's not how you spell choose, that's how you spell chose. N, choose, r. Permutation of n, choose, r. And the reason why we do that is because we're really taking a certain amount and we're only choosing a couple of those things. So for example, when we did our little game over here on the whiteboard where we picked numbers, there was 10 numbers to pick from. How many did I actually pick? Anyone remember? You picked 5, right? Okay. You picked 5 that were out. If you didn't remember, that's okay. That was from our Fun Day Friday. All right, so when we pick them out, that's choosing them. We're picking them. Okay. On Desmos, I'm going to write this out so that we have that. Really important that you know how to find this because you'll need to know it's a really complex formula for it. You're going to go to the water fountain or are you going to the bathroom?
Bathroom.
Bathroom? Why does it say water fountain? Then you got to make one to the bathroom. All right, so on Desmos, what's really important is the first thing that we're going to do is we are going to go to the Func menu, F-U-N-C, the Func menu. And then in the Func menu, we are going to hit NPR. And then we're going to go back to the main menu and do number, comma, number. So again, this looks really silly until we actually do one, but this is how you type it into Desmos. That's going to be a really important part. Your first question on your quick check today is literally just typing it in and seeing if you can get it figured out into Desmos. Okay, you need to go quick. So fast. All right, we're going to do 2 examples today. So for our first example, we're going to talk about this attendance award. First example. Okay, so we had an attendance award, I think, first trimester. Last trimester we did it for grading. And we're going to give an award out for the first, second, and third place winners of attendance for a certain group of students. So we sent out an email. We said, who wants to participate in this? We got back some information. We said there's 5 ninth graders or 5 freshmen. There's 9 10th graders or 9 sophomores. Sophomores is a weird word. There's an extra O in there, so we don't really say sophomores. And 3 juniors. That said, yep, we're going to do this attendance award for these people. Maybe we picked like the people that really needed help figuring out their attendance. Maybe we just picked out the top. Maybe we looked for volunteers. Don't know. Alright, so as we figure out our permutation, we need 2 numbers. The first number we need is our n, and n stands for our total objects. So as I look at my n, I need to know how many total people are there that we're picking from. So how would I find my total people? Yeah, just add them together. 5 plus 9 plus 3. This is in that bin. I think there was one person from this class in there. I can't remember. But maybe not. I might be wrong. All right, what is 5 plus 9 plus 3? You sure? Yeah, 17. Good job. You're so smart. I don't know. Adding 9s is hard for me. It takes an extra moment for my brain to process. All right, so our n is 17. Now our r is how many people are we picking? How many places are we trying to find? So how many awards are we giving out for attendance? 3. All right, so in our calculator, we're going to do that N, P, R. Of how much are we starting with? How many objects are there to choose from? 17. And how many are we picking? 3. So in my calculator, I'm going to follow that Desmos. I'm going to go to my function menu. Function, it's at the top here. We find that NPR down here at the bottom. There's also an NCR. Get ready for tomorrow. It's going to blow your mind. We'll use that one. I need to go back to my main menu, and I need comma. So 17, choose, comma, 3. And it tells us that there's 4,080 ways we could have first, second, and third place. Now, another way to do this in Desmos, especially if you're using your computer to do Desmos, is you can literally type in lowercase n, uppercase p, lowercase r, and it'll recognize it as that function. You just have to make sure you put in the parentheses. Okay. When you do the func menu on here, it'll automatically put the parentheses in. But if you just type it in exactly like this, it will also do the same thing. Okay. All right, we have one more problem here. This one's a little bit longer. This time we're actually going to find probability, not just number of outcomes. So we're on number 2. Number 2, we're going to talk about the iPhone passcode. And for an iPhone passcode, we're going to do the 4 digits. And no repeats. So again, we're trying to keep this a little bit more basic. Next chapter, we can figure it out with the repeats. This chapter, we're doing the no repeats. With repeats, it gets a little bit more complex. Okay, iPhone passcode, 4 digits, no repeats. All right, and I want to know what is the probability that if I randomly pick a passcode, what is the probability that it starts with a 3, 6, and then something, something. So if I just randomly pick an iPhone password with no repeats, what is our probability that starts with 3, 6, something, something? Start a little bit lower. On number 2. So this one kind of has 2 steps to it. We have our first one that we are going to start with, which is just finding our total sample space. So we want to know how many total passcodes are there to choose from. So when I do my total sample space, it doesn't matter the order we put the passcode into our phone. Yeah, if you put the right numbers in, but you put it in the wrong order, does your phone let you get in? No, so order matters. And here we're going to take that order matters, so NPR. And we're doing our digits. So when we look at an iPhone passcode, I'm going to try and do this without using my Face ID. Can't look at it. When we look at an iPhone passcode, here's all the digits we have to choose from. How many numbers are there to choose from in a passcode? Yeah, 10. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and we have 0. So 10 total. So there's 10 to choose from. And how many are we going to be picking? 4. So 10, choose 4. Okay, so to get to that, we go to our Desmos. We're going to hit this func button at the top, NPR at the bottom, and we're doing 10, 4. Right, and we get 5,040. So there's 5,040 different passcodes we could come up with total. Now, when I have a passcode that starts with 3, 6, and then something, something, how many spaces do we still need to fill? Okay, so we need 2. So we need 2 spaces. And there's no repeats. So originally we had 10 numbers to choose from. If I already used a 3 and I used a 6, how many numbers are there left to pick from? Yeah, there's 8 numbers left. Okay, in your Schoology Quick Check, it's going to kind of ask you those questions like how many more do you need, how many spots are left, and then how many things are left to fill it. There's 8 numbers left. So if I look at our 3, 6, space, I'm going to look at that NPR. And how many numbers do I have to pick from? 8. And how many spaces do I need to fill? 2. Now, if I accidentally put this in backwards, if I did 2, 8, I get 0. Is there a way to pick 8 things from two objects? No. So that won't work. So if you ever accidentally get 0 there, you'll know that maybe you put it in backwards. So 8, 2, we get 56. So for our last step here, it wasn't asking how many outcomes it was asking for our probability. So probability, we use just the capital P. So I want the probability that it goes 3, 6, something, something. If I randomly select a passcode, which no one ever does, we all use like dates and numbers that are important to us, right? But just pretend. I want to know what's the probability that starts with a 3, 6, something, something. So how many passcodes start with 3, 6? $56, yeah, sorry, I didn't hear you. 56 out of how many passcodes total did we find? 5,040. So when we find that probability, we're putting it in that fraction form. We can simplify it, maybe. This one, they're both even, so I know we can simplify it. 56 out of 5,040. We get 1 out of 90. And what's our 2 other ways to show probability? Percent and decimal. So as a decimal, it's 0.01 repeating. 1, 1, 1, 1, 1, 1, 1, 1, 1. So I'm going to put that little dash above that 1, saying that 1 keeps going and going and going. And if I just round that to the nearest whole percent, I would do times 100. And that's about a 1% chance. It's kind of crazy, right? I mean, I guess. But if you all just randomly pick a 4-digit passcode, there's only a 1% chance that you picked one that was a 3, 6, something, something. Feels like it would be more than that.
So this is another situation where you actually see math in real life. Remember when like Apple and your phone used to just come up with a 4-digit number? And it's only 5,040 ways to actually do it. So it's so much easier to hack your phone. That's why they introduced like 6 digits and 3 and everything. So 6 digits is going to be a higher number, so it's harder to crack your phone.
And then if you use repeats, it will increase that. But again, with those repeats, that's going to get into a whole next chapter. When we talk about mutually exclusive and not mutually exclusive events, really fun. All right.